Okay, so get the const here. Okay, so now it's about implementing the ShareCode import and export. Okay, so I mean we have already implemented this, tested this a bit, like this should work for the most part. We already talked about how the format, right? So you have the format, which is just stateless, or like it doesn't save the data, it only saves the format. So what data each property contains, how big it's allowed to be, and so on. You get the data, you assign the property values, and then you pass it to generate the string. And I mean here it means it's reusable, right? So the user can store it or just produce a new one. Obviously, yeah, on any changes the user needs to regenerate the ShareCode data, which is I guess the first thing we actually have to check, right? So I have to do a couple of things. We first have to check is the data equal to the properties, if they're the same state, same, yeah, okay, here we can check, right? So we have to do a lot of checks here, because we can, right? Because we get the whole data and we just return a string. Right, so here's the ShareCode. So we can already, I guess, yeah, but that comes later. So first the equals check, then the hash, right. So now, yeah, the whole generation thing comes into play. So yeah, I mean we can leave this in here, I guess, implementation note. So about the concrete format. Let's make this like this. Format. Get a bit of nice. So version header. Format. Let's actually copy this. Let's make this like 2 tabs. Like a nice layout. So we have a version header, which is this, which is 1 byte. And 1 byte I can store a number from 0 to 255, which should be enough versions. I mean, this is mainly just, yeah, I mean, it's just kind of a common thing to do, right? To save the version. Yeah, I mean, I guess you could check, but I wouldn't make them backwards compatible, right? But you can, I guess we can make a version. Right, so what I like to do here is if I need a free function inside an implementation function like this, I put them right above, right? And I just stack them right above. So I can make, and also free functions are always capitalized, the first letter, same as static functions. And camel case, alright, camel case. Yeah. So is version valid? So in here I can just hardcode the valid versions. So I already make like this, so I can copy it later on if I get past a uint version. Yeah, I can make this. If version equals 1, return true, return false. Right, and in the future I can just make this a range, right? I can say like maybe version, the last 3 versions are valid, the rest is not backwards compatible and so on, but yeah. Right, so first I do the version check, so and also I have to think about what I return if it's not valid, right? So what I do here, I make a failure node, a failure param, or like a documentation. If Right, I mean, so what I'm thinking about, usually I specify exactly what can go wrong and what it does. So if the past pointer is null, this happens, right? But problem is that a lot of things happen. I do the version check, I do the property check, I do the hash. Well, actually the hash can't fail. But yeah, so I just kind of make it more generic, I think. Actually, the version check has to be done down here. There's no version check in the generation yet. Right, so I guess if I can specify it directly, then if the past data is I'm just going an error returns empty string. Right. Yeah, and the empty string doesn't allocate, right? Return. I guess I can actually leave it empty because here we're gonna reserve the string. Yeah. Okay. So where were we? Okay, so first I guess the equals check, right? So I just do for const because we don't mutate data and data properties. P, I don't know. That's previous deck. Oh, what is it? Oh, okay. Auto PD, I guess. Actually, it needs to be the exact same order, right? So I can't just int size. Color properties, that size. Cast it on int. Int size equal size. Cast it on int. If data size format size return empty, but literally empty. Commit to con, so I don't actually need these numbers anymore, right? So in here Can just use either one. Const auto reference dp equals like this, and then fp like this, and then if dp dot bits unequal fp dot bits or dp dot type unequal. Yeah. The name. So yeah, for the bits, the name and the type, they all have to be equal. And we of course want to log some warnings. So, I mean, here we want to say given data layout does not match the format. Use get format data to get current t. Exactly not the same line. I guess I can make it like this. Right, I guess this would be the checks. Yeah, I mean, I can be my const, sure. And no discard. Okay, so now we want to calculate the reservation and total data bits. You definitely want to use the bits here and the naming, so it's clear that bits, not bytes, equals 0, then p and properties, so I just use p now because we only have one p instead of the two. Data bits. If, yeah, but the problem here we have the string, which, yeah, we just handle immediately. It's just like no reason. So we have an empty property here, which just make it 0. And say -1. Oh, there's one -1 here. And get bit size. Is that's actually to be renamed. Right, and then for the this f is same const just we return string length of the argument, which is bytes then times 8, which should be correct. And then we can modify this, we can pull this out. We talked about last time, get the bit size. Where's the assign actually? I'm not seeing the assignment. Interesting. Oh, it's only setting the data. Right, so it's already set from the initial. Yeah. So I only need to set it for the string. So I guess I can check here, free the string, p.bits equal bits. Okay, so now I don't have to change anything. There's no special case for the string. I can just do it like this and get the deterministic size up front, right, in bits, and then I can reserve and do just like this, total bits, but in this case it's bits, so divided by 8, so that actually leaves me with less. Damn, it's actually the other way around. So now, for example, if I would have 15 divided by 8 would be rounded down to 1, I'm pretty sure. So I need to what's the it's a size type, so it's an int. I mean, I could seal it, right, and cast it back. I guess that's the play. Interesting, so then default seal is not. Why is that? Do I need to include CMath? I don't understand. Interesting. Okay, so we pre-allocated up front, 0 terminated. Yeah, I'm going to use a string here because you can modify it, but I guess you're actually not supposed to modify it. But the lifetime of the string is just way easier, right? It's automatically cleaned up. Yeah, as a library, you want to return something like that, where the user can make a copy, but it's already allocated, but it's safe. That feels nice. So we already did the equals check. we can actually do a check here. Don't we just return empty, right? Nothing to do. Yeah, and then we still need to add. So actually, let's comment this a bit. Accumulate size. Add static size. Total data bits. So by 8 bits. The format, the version, and then 16 bits for the hash. So, and the hash, what does the hash do? So, I already talked about how the format. Because of the format, you don't need to specify the format in the shared code, right? So the shared code just contains the data, which makes it leaner and smaller. Yeah, which is good because I mean it's copied around. It needs to be parsed back. Yeah. What that does is you have to know the format when you import the ShareCode, right? Otherwise, you can't interpret it. So it's right here. You import this from string, and it's called on the object. So you need a ShareCode, you need a format object, and then you get the string. But you don't know in which state this format object is, right? So while it could be the same, well, actually, you don't know anything, right, when you import the string, because the user could generate it from one format and import it from the other, and so on. And when importing, so you want to encode at least something about the format inside the ShareCode, so you can do some basic sanity checks and just help the user find errors at a very low cost, right? And instead of saving the whole format, like the numbers and everything, you only save a hash code, basically a checksum, right? You just calculate, maybe I guess I should actually call it as a checksum, which is just, I mean, it's actually a pretty small, right? 16 bits, maybe should make it bigger. But I mean, it's just a sanity check, right? If you have some collisions, it's really not that big of a deal. Yeah, the checksum is then just a separate thing. Yeah, the problem is, yeah, that's always a bit annoying because I don't want to make extra methods here. But I can't access the private member and outside methods. Yeah. Yeah. So the only play is either make a lambda, but then it's still inside the same method. Yeah, it's a bit annoying. And also don't really need a public method for the checksum. It's just maybe I could actually make like a well, I guess I actually do, right? What I actually can do is I can make a struct ShareCode, because I actually haven't done that yet. Then just make it a string name. Maybe I actually make it a const char now. I mean, it should be, but then, you know, the allocation. But I mean, I can manually do it. So the main thing being why I think about the, I think about it not being a string as just the includes, right? Wherever I use the ShareCode, I have to include the string, which is annoying. Yeah, it just saves compile time. Yeah. I don't know. I guess I actually make it a construction, right? There's nothing. You shouldn't mutate it. If you regenerate it, you regenerate it. You don't like change it in place. It's actually very, very good use case. Yeah, just empty constructor, which should actually be private. Friend ShareCode format. So you can generate it. Then we actually take it and return it. I mean, this also feels nice, right? Having a dedicated type. This can actually also be made const, right? Right, so we still, yeah, we're actually not using a string here, right? We already allocate the usage, like auto pointer, p data. I don't like that. Just code data. Yep. Yeah, but I hate this. Damn. Allocated memory is leaked. Damn. Scary. Scary, scary stuff. So I actually make ShareCode here. ShareCode. I could actually already allocate it. ShareCode. Code equals this. Then implement this. Make this clear. Make this the format. I guess we can use a malloc for this. Problem. I'll just stick to this. Okay, so it's not leaked anymore. We initialize this to null. Save. Make it 4 bytes. Let's see. I mean, this is the Evolve 1, so it has like I would guess these first 3 are like the version or something. These are like, yeah, so it's, I don't know. I like the header in some way. It's only 3 bytes, right? It's like first one. I guess that's the version. And then 2 bytes would be checksum. Yeah. I guess I'll stick to that, right? Okay, but here I can get the checksum. Checksum. And he gets checksum. Sends the checks some of the format. Useful, because you can use this then, because that's why I wanted it just now. Because now you can at runtime determine which format the string, the ShareCode belongs to, right? This is something you couldn't do previously. So last time we talked about, for example, in World of Warcraft, where needing the format to decode the ShareCode isn't really a big deal, because if you have like the talents, right, you export the talents and you import the ShareCode in the talent window, right? And then on the software side, we have statically coded the importer and the talent window, and it's always going to be the same, right? But this system now, even so, on top of this, just statically doing it, it even allows you to dynamically search for the correct format. So if you have like 5 different formats and you get a code, and then just iterate through them, check the checksum. If the checksum matches the checksum of the ShareCode, this is very likely to be the correct format. Checksum of matches the checksum of the format. Format. Right, so document it, give the user a concrete hint on how you imagine this to be used. I like that. Sure, I'll discard. Okay. So now we actually have a method checksum. We don't need a free function for it. Can do like get version. I mean, the user actually doesn't need to know this, but version. Right, we can make like a Java interface. Let's make it buff. It's kind of long, but I think it fits. Actually, now to think about it, I like to use like the correct name. I guess it's just kind of type name. I like it if it's used in documentation as well. Okay, Just search for it. Exact search. Yeah, so I don't really need to. I guess I can do. Just replace them. Okay. Do we actually need the string anymore? We don't. Saves compile time. Okay. So we get the version, we get the checksum. Whoops. Okay. Can implement this first. Return the version. Okay. So we do get closer. So the checksum. It's not an interesting thing. Right. Interestingly enough, yeah, I mean, this is later. Just do the checksum first. So the checksum is basically like the hash function. I mean, I guess there's no real hash function. No, there is actually C++, of course. So like the hash implemented for your type, like in Java, the override. So you wanna acknowledge every unique element, or like every element actually of this class, kind of incorporate it into the hash, because yeah, later on it's used yeah, to basically do an equals check, right? Like this is an equals check, but without actually doing the equal checks. But you basically transform all the data in the class into like a representation, like in a lower dimension, I guess. Yeah, because then you only need to compare one number instead of like many numbers. And I mean, this is not lossless, right? This is just a hash. You give up some you give up like deterministic element, right? If two element, or if you equal check two equal objects, they will always have the same outcome, right? Because they're just equal. But if you generate a hash, it can happen that two objects that are not equal turn out to have the same hash, right? And in this case, if you only compare the hash, you would find out, oh, they're equal, but actually, like logically, they're not equal, right? So this is the relationship. But yeah, usually the hash code is just fast to compute, or you can cache it, and then for example, in the hash map, where you use that exact logic. So the only element in our class, in this case, what format is just a properties vector. So yeah, we just have to use the hash code, like this here. Well, actually, I guess what we do, we just generate 64 bytes number, the sum, and what are we doing here? First we have the bit value, some bits, I don't know, what are we doing here? Sorry. I actually have it not bound on my keyboard. I don't know what it's called, but the XOR operator is usually something. I don't know what else. We can do an AND, but an AND is not really good. I can just copy it. So we just XOR them. I guess there's no real need to cast them. Can't use randomness. Can use p access and properties. That's size, I guess. It's like a starting value times say constant, maybe. Right. So this could overflow, but not really. So we start by sum, value, then we plus equal. I don't know, I don't necessarily like the plus equal. We do the head equal with the bits. I mean, that's with the bits XORed with the name. What happens here actually? It has no like. The type. Why does this not actually work? I guess because it's typed. So we do this. XOR with 0. What does actually XOR with 0? Is this a special case? Right, shouldn't be a problem. It's just a number itself then, so it's just an empty operation. So if p.name equals null, so I want to do something. If it's null, then I just maybe add a constant, maybe like this, and else I iterate string lang this cast an int just to be I also like the completion on the static cast because I hate the static cast, at least how it looks, you know, but I read up about it and I actually deliberately made it all ugly because an operation that, you know, interferes with the type system is supposed to be ugly, which I don't know, I like the sentiment, you know. So I would even go as far as to only use static casts, just to discourage it, but also just to make it very explicit, because I don't know, I like type safety. It's just nice having deterministic compile time deterministic or determinism. And then just sum plus equal the name character. I guess that's fine. And that's it. Actually, there's no more properties. Just give it ChatGPT. So, because there's like many pitfalls with these checksum functions, because you need to kinda just do a few operations correct. Right, and the modular, right? So this looks fine. So I start with the same base multiplier, like so. We switch, then it uses prime number. This is, I guess I've seen this out of hash functions. Multiply with the prime. And then, yeah, XOR folding and modular. I don't know what XOR folding is. Let's ask. Interesting, interesting. I mean, it sounds really nice. Something like this. Like this. Custom. I mean, this looks nice, right? So basically you do a bit mask, the lower, the upper, and you just sort them together, and you just do it again. And yes, it is const. And not discard. Right, I mean, yeah, this should be a solid checksum. Okay, so we can continue here. And the good thing is, why I wanted to make 64 bytes bits, that we can just freely decide, right? If you want to just have a bigger checksum, yeah. Okay, so we do have the final size now, and now we can start iterating. The thing is, I guess we can make it like this. So I have a total bytes. Right, and this can be implemented later. Yeah, I mean, that's nice. Okay, so now it's about filling. So, yeah, about the sub-byte filling is gonna be interesting, but for now let's just fill in the other version of the checksum. So I have the ShareCode code. This is kind of a bit annoying, but it's, I guess, 0 equals it's actually already char, right? So I can set it cast it to char. Actually, I wanna do this another different way. I don't wanna. Let's call this string data. Let's get our ShareCode back. Okay, so I get the version and then just do a mem copy. Is this, I guess, total bullshit. We copy it to. What am I doing actually? Yeah. So copy to the one. Take the address. We copy from the checksum. Get checksum. Nice. Copy from the checksum. Checksum. Okay. Alright, statics. And now we overwrite the things. Actually don't need to. And current 0, but it's actually 3, but in bits it's 24. Right, so for total data bits. Okay, so how do we actually do this? I mean, I guess just mem copy, right? It's really not that big of a deal. I would actually go then current byte. Then we iterate along the total bytes. And then we get the current character. It's actually 4 because 1 passed. Current bytes incremented, and then we write. Yeah, I guess I can't do it like that. I need to iterate like this. But I still need current bytes. And current bits again. Bits. It's 25. Then I need a constant current byte. But I need a seal. I do a mem copy. Right, so because I can only copy on a byte level. That's actually interesting. So I guess I need to just use operator or. Right. And then current subbits. Times 8, I get how many bits I'm in, and then I can shift this to the right for the current subbits. Guess this doesn't work. I guess I can just do like this. So then I can't write across boundaries. Interesting. I guess I have to ask ChatGPT. Actually, data properties. It's actually not that trivial. Okay. I guess need some heavy shifting. So that's what damn. So what do we have here? I mean, I have the value, which in this case is actually wrong. Okay, so I mean, yeah, the value and the number of bits. Right. So I guess you need a while loop to handle the running across the byte boundaries. But I don't get it. So I mean 25, right, so I'm already in a new byte. So I guess that's correct. The byte index, then the bit index in the bytes. Yeah, I mean you can use the modulo, but manually is probably faster. So I get 1 here. Available bytes. So yep, I just have the 7. The bytes right now is the min between the two. Okay. Now mask to get the bits we want from the value. Okay, that makes sense. So my value a bit shifted to the right. Why to the right? I mean, I want the first. Have a number. Shift it to the right. I suck up the things. But I actually wanna go from the other side, no? I don't know, this is kind of confusing. Bits left to right. In this case is 7. And I want to write 4, for example. So I shift by 3. And okay, I don't understand this. I don't really understand this. So 1 shifted left, but a bit to right now. So I get a power of 2. But so I get a, oh, I actually get a mask, which so like, yeah, I just get this. So by this I basically have a 1, which is just this. I shift it left. I want to write like 4 bytes, right? 1, 2, 3, 4, like 3. Then -1, right? So it actually goes to this. And then I AND it with the bits up above. And above is like the value. Let's say the value is something bigger, like this. Right, and then it's shifted to the right by the bits left to right. In this case I have 7 left and I want to write like 4. So it's like 3. I shifted to right by 3. Like this. And then I AND them. And this is my right. Interesting. Yeah, so I cleared the... So here again I get the mask. I shift it left by the bit index. Okay, now this I get. I shift it left, for example, like here. The bit index is 1. Wait, I only shift 1. Why I only shift 1? So I have like this. And then I invert it. Okay, that makes sense. Hey, but then here's like 1. Like everything. Is this actually an inversion or not? I don't think so. Okay, and then I write it. So the bits to right. So I shift them again. Jesus. So the bits to right from above. Something like this, and then I only shift them by 1. To the left. Why? Still. Alright, and I just add them. I mean, sure, right? Can work. Let's test it, I guess. So I want to get the ShareCode now. Oh, get ShareCode, the data I provided. And let's see. We should get into E already. Right. What am I doing? Interesting. Interesting. That's from before, because we removed the property. Definitely should match. So we should get into here, of course. We do. So the size is the same. Okay, so inequality. Interesting. Of course, the name comparison is wrong. It's if dp.bits. The name. Name. That's actually a funny thing, a funny little thing. So if either string, wait, is it true? But I mean, this is really cool. Comparison method. I don't know. ChatGPT will tell us probably. So I'm just gonna write it out, I guess. tp.name and fp.name or fp.name. Or dp or fp is null, but the other is. That's wrong. Else if so now both are either null or valid, right? So if something like this. So I mean, this should be correct. So here, if dp.name fp can't be null. Okay. Excuse me. Okay, what's the deal? What's the gist, physicist? showing 0 bits because it's not set. That's annoying. Because of the string. Yeah, so that's the problem. So I guess I do want the maximum size up front. But I don't wanna pad it. I guess I can skip it. Whoops. Okay, so we get through there now. So we iterate until here. 49 is the total. Is that correct? 32. I have to name that as 0. I have to go through data properties. 89. Which is 40 bits, 5 bytes. Okay. So the thing is actually, I guess, so we're wasting 1 byte actually by null terminating the string. But in turn, we don't have to specify maximum size, right? So I don't know what's better here. I like that it's not necessarily maximum size, but because I don't know if I get a maximum size, I kind of have to pad it, right? I would just waste a lot of space. That should be fine. So it's not 0, it's correct. Okay, then I'm at 113. Which gives total size of 15, is that correct? Yes, it is. Okay, so I have our data, we get the checksum. What's the checksum? 13k. Set the version. Okay, let's check the string data. I mean, it's pretty short. /x1. Version actually is 1, right? Or is it a slash? Oh, it's /x, I see. So I guess it's actually correct. Looks like the first ASCII are always these control characters. Let me see. I guess I don't really show it. Right, and then the rest are like these two bytes. I mean, sure. Yeah. Okay. So I get the value. Right. Oh, yeah, we have to actually have to switch. Interesting. I mean, so maximum it can be 8 byte, our thing, right? It can either be a double or an int 64. Or a string, for that matter. So... I mean, a string is pretty easy, right? But then I guess I just have to switch for the numbers here. And just make... I can't... Doesn't matter actually. Yeah, I might have to make an abstraction for this. This is too much. Generic. Yeah, how do I do this? I mean, it actually can. So at most it can be 64 bits anyway, right? How do I then set the data? Just like everything else. But do I even provide a generic then? Or it's... I don't know. I don't think so. So slash if you type is less than floating, we get in here. So where's the string? There's the string. Right. Let's remove that. Wait, but how? So I only need to percentage. Otherwise, I just don't care. Interesting. So I could just make a switch. So for the floating, it's way easier. I can just copy directly. Well, I can't. Fug. And for the text I also can't. Unless I pad. I don't want to. Oi oi oi. Oi oi oi. I mean, I guess I can just reuse this. Yeah, I mean, so what I need to do, I need to make a method, write bits, and then I can just either write an integer or a float, right? And for the string, I just write the byte value, and then I guess I can just get away with writing only the 7 bits per character on the string if it's ASCII, right? That's also funny. But then I mean, reading, I guess I can't read it back. Then yeah, I need to write it. Yep.